Welcome. So at this point, you should have tried all these problems. I'll go through here and work them so that you can see if you got them right or wrong. So number one here, we're asked to factor by grouping. So the first thing we really should check for is a GCF, but there's not one. There's nothing that divides all four of those terms. So then I look at these two terms. What divides out of those terms? Well, that would be 4x squared. And if I divide 4x squared out of both of those, that's going to give me a 3x, and then 8x squared divided by 4x squared would just be 2. In order for this to work, I need this to be a 3x minus 2. What do I divide out of that to make that work? That would be a 3 with the minus sign. So common is a 3x minus 2. And left over is the 4x squared minus 3. There's that. So that gets letter A. Letter B, what's common between those two? That leaves a n squared, and that would leave a what? 4n plus 1. Over here, I want a 4n plus 1 to make this work, so I'm going to factor out, what do I factor out? An 8, but I needed to change sign, so a negative 8. That means I'd have 4n plus 1, that's those, and then I'd have an n squared minus 8, which would be that. So there's that one. The next one looks a little bit different. Same technique here. What comes out of the first two? Well, that's an a, and that'd leave, if I divided both of those by a, that'd leave b minus 3. And then over here, I want a b minus 3. So I would factor out of those two a 5, and I'd have b minus 3 and a plus 5. So there's number one, A, B, and C, factor by grouping. Number two, factor by splitting the middle term. So again, there's no GCF, so I multiply first times last. So it has to multiply to be 20n squared, but add to be 9n. If we do a little bit of inspection here, we'd get 5n and 4n. So I'm going to take this 9n and split it. 4n squared plus 5n plus 4n plus 5. Now, same drill as above. What comes out of those two? Well, that's going to be n. That leaves 4n plus 5. And I want a 4n plus 5 here, so I'm really only pulling out a 1. So what do I have? I got 4n plus 5 and n plus 1. And that gets me that one. No big deal. This one is not too bad. What multiplies to be 100x squared, but adds to be 29. Well, that's 25x and 4x. So I'll split that middle term. So what do I have? If I factor out of that one, a 5x, that's going to leave me a 2x plus 5. I want a 2x plus 5 over here, so I'm going to factor out a plus 2. So this gives me 2x plus 5 and a 5x plus 2. So that gets me that one. The difference of two squares, this works out pretty nice. We need to recognize a pattern. So this is just 3n being squared, and this is 4 being squared with the minus sign in between. So this is always going to factor out as 3n minus 4 and then 3n plus 4. So it's the same thing. It's what they call a conjugate. It's the same elements with the change in sign in the middle. You can see that this works out. It works out pretty nice, and why it works out. So 3n times 3n is 9n squared. 3n times 4 is 12n. That's going to be a negative 12n, and that's going to be a negative 16. And you can see what happens to those middle terms. They just go to 0. So you can see that it does indeed get us back to that original. For the record, though, that's just me checking it. The actual answer, the factored form of this, is that right there. So let's apply this to these others. This is 6b being squared, and that's 7 being squared. So that's going to be 6b plus 7, and 6b minus 7. And order doesn't matter. You could have it as 6b minus 7, 6b plus 7. The order here is not super important. Here, so again, either one of those is fine. Here, it's fairly obvious as to what is being squared there, so this is just going to be x plus y, or x minus y. Or we could go the other way around, x minus y, and then x plus y. It doesn't matter to me which order you go. And that gets you your warm-up done.